convert each angle in degrees to radians and round to 2 decimal places. So here I have 18 degrees. All right, to convert from degrees to radians, we will take 18 degrees and multiply it times pi over 180. Now, take your calculator. What you will need to do here is you will multiply 18 times the pi button and divide it by 180. So do that on your calculator. 18 times the pi button, which is the 3.14, so forth on. Multiply those together and then divide it by 180. If you divide by 180, you get 3.314159, so forth on. But when you round it to 2 decimal places, your answer should be 0.31, and that is in radians. Okay, that is in radians, because you were going from degrees to radians. All right, let's look at the next example, 200. So you multiply 200 degrees times pi divided by 180, and again, that is radians. Okay, so take your calculator, multiply 200 times the pi button divided by 180. So if you multiply 200 times your pi button on your calculator, then divide it by 180, I get 3.490. So I have 490. Now, does 9 need to stay a 9, or does 9 need to become a 10 and make this become a 50? Well, you look to the digit to the right. If this number is 4 or less, 9 stays the same. If it's 5 or greater, you go up from 9 to 10. Being that this is 0, this 9 stays a 9. So my final answer is 3.49 radians. That's how we would work this problem and round it to 2 decimal places. Let's convert each angle in radians to degrees, round to 2 decimal places. Number 1, 2 radians. Well, let's recall that to convert from radians to degrees, we will multiply the radians by 180 degrees divided by pi radians. So we have 2 radians times 180 divided by pi radians. The radians cancel, so we end up with 2 times 180 divided by the pi button. Well, 2 times 180 is 360 divided by the pi button. So take your calculator and say 360 divided by the pi button, and you get 114.591. Now you're supposed to round it to 2 decimal places, so 0.591 leaves it 0.59. So we are changing it to degrees. So my answer would be 114.59 degrees. Next, we have pi divided by 13 radians. Let's convert to degrees and round to 2 decimal places. So we have pi divided by 13 radians times 180 divided by pi radians. The radians cancel, and actually the pi's cancel. So we have 180 divided by 13. So punch in your calculator, 180 divided by 13. I end up with 13.84615 and a few more numbers. Now we're supposed to round it to 2 decimal places. Rounding it to 2 decimal places is right here at the hundredths place. Does this 4 need to stay a 4, or does it need to become a 5? Well, you look to the digit to the right. If the digit to the right is 5 or greater, then this 4 does become a 5. So I'll need to round that to 0.85, and this is degrees. So your answer to that problem is 13.85 degrees. Next, I want us to draw an angle in standard position. I want us to draw an angle in standard position. Now, let's just talk a minute about our quadrants that we have. This is our x-axis, this is our y-axis. This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Quadrants go counterclockwise. Now think about it. This is 0 degrees. A fourth of a rotation here is at 90 degrees. If we go on further, another fourth rotation, or a half of rotation, you'd be at 180 degrees. Then coming on down, you're at 270 degrees. And then if you come back around, 0 or 360, a full rotation would be at 360 degrees. Okay? Now, I have 7 pi divided by 6. So let's convert this to degrees. Okay? Now, recall, to convert to degrees, I have 7 pi divided by 6 time, and if you're converting to degrees, multiply it times 180 divided by pi. The pi's would cancel, leaving 7 times 180 divided by 6. So here I have 7 times 180 divided by 6. Therefore, this is 210 degrees. So if we were going to draw this angle in standard position, remember your vertex is at the origin. Here is your initial ray. Now, 210 degrees. Remember, to draw your initial ray is here. You draw an angle in a positive manner by going counterclockwise. So if I draw this angle here, I would go around, this is 90, on to 180. Now I need to go down to 270. Well, I'd come down 30 more degrees, and here is my terminal ray. So this would be the angle 210 degrees, which is the same thing as 7 pi divided by 6. So this terminal ray ended up being in the third quadrant. So here is an angle in standard position going past 180 down to 210. So therefore this is an angle in standard position. Let's look at another one. That's a positive angle. All right, let's draw this angle in standard position. Negative 5 pi divided by 4. I'm going to change that to degrees. So I have negative 5 pi over 4 times 180 divided by pi. So then the pi's would cancel. So I have negative 5 over 4 times 180 over 1. So if we multiply that, negative 5 times 180 is negative 900 divided by 4 is negative 225 degree angle. So we're looking at negative 225. Now let's keep in mind, here's your vertex, here's your initial ray at 0 degrees here. Remember, this is 90, this is 180, and this is 270, and then back to 360 all the way around. Now, this angle's negative. Now, recall, we talked about negatives go clockwise. So this is like negative 90. If we're going the negative direction, this would be like negative 90, negative 180, and then so forth on about 45 degrees. If you say 225 minus 180, you get 45. So you're looking at about a negative 45 angle right here. So this would be negative 225. thinking this of negative 90, this is negative 180, and then on 45 more degrees, you're looking at the terminal ray being over here in the second quadrant. Remember your quadrants, 1, 2, 3, and 4. So this would be the standard position of a negative 225. So here would be your angle there. I'm darkening these in. Here's your initial ray all the way around, and this is your terminal ray of the negative 225.